Welcome to yet another video on SRID Cloud. In this video, I want to talk about setting up a BGP configuration between a couple of Cisco routers, and this time it will be the ASR 9K routers, which is running the IOS-XR software. So until now, in my previous videos, I always used ASR 1K, which is running IOS-XE. And now this is IOS-XR, a little bit different. So in this topology, I have a very simple two subnets, 192.168.10 on the left and 192.168.20 on the right. Each of these subnets are deployed with a switch and also a gateway on the router, the ASR 9K router. And for testing purposes, I deployed a PC. So for example, on the 192.168.10 network, I have the gateway on the router, the first router, which has the ASN 64999, and its IP is 192.168.11, and the PC has 192.168.12 as its IP. And in the switch, I have configured VLAN 100, and the connectivity to the PC on the switch is an access port, and connectivity to the router on the switch is a trunk port. So the same thing is duplicated on both sides. So let's take a look at the runtime configurations on both sides. First, let's look at the PCs. So here is the PC one that is on 192.168.10 network. Let me show IP. So 192.168.12 is its IP, and gateway is 192.168.11. And I should be able to ping its own gateway, 192.168.1.1. And now let us go to the PC2 and verify the same thing. So its IP is 192.168.22 and gateway is 21. Make sure the IPC is able to ping its own gateway. And it is working fine. Now let me switch over to the switches. One on the left, so the gigabit Ethernet 00 and 01 are up. And now let's look at the runtime configuration. As I mentioned earlier, one of them is access port, the other one is the trunk port. As you can see, the gigabit Ethernet 00 is a trunk port connected to the router, and the gigabit Ethernet 01 is on VLAN 100, is an access port connected to the PC. So we should be able to see the same thing on the other switch as well. It's the same thing, and then runtime configuration. Trunk and access ports are similar. Now let's look at the routers, the ASR 9K routers. So this is the first router, and let me log into it. And first of all, look at the interfaces. So what you see here is the gigabit Ethernet 0001 that is connected to the other router on NIC 3, and I have a bundle ether bundle ether 1 and its subinterface bundle ether 1.100. This is the equivalent of the port channel on the IOS-XE. This is where the difference is on the IOS-XR. And this bundle ether 1 is added as a channel group in the IOS-XE terminology to gigabit Ethernet 0.0.0, 0000 actually. But here different terminology is used as a bundle ID, not the channel group. So now let's look at the runtime configuration. First of all, there is a VRF. I added VRF to this configuration just to make it more valid. There is a route descriptor 1.1 and the address family IPv4 unicast is enabled, and I have to import and export the same route target in this section. And then here is the bundle ether 1, and this bundle ether 1 is added to the physical port gigabit Ethernet 0.0.0.0 with using the bundle ID keyword. In IOS-XE it is channel group, but here in IOS-XR it is bundle ID. And this bundle ether has a subinterface for the VLAN 100. It is under the VRF as well, and there is encapsulation .1Q100 is also enabled, and its IP is 192.168.1.1. This acts as the gateway for the 192.168.1.0 subnet. And also on the gigabit Ethernet 0.0.0.1, I put the same VRF actually to keep things simple, and its IP is set to 172.168.1.1. As you can see in the topology diagram, there is a transient temporary network, I should say, between the routers, and it is very tiny, /30, and it is 172.168.1.0 CIDR, out of which 172.168.1.1 is on the first router and then 1.2 is on the second router. So now let us look at the rest of the configuration on this router. Nothing much, but there are a couple of important things. There's a route policy enabled on this router. This is I think very unique to IOS-XR, could be wrong, but this is required. The pass keyword in the route policy says pass everything. Basically the route policy will be applied to the BGP down below, and this route policy pass keyword says don't restrict anything except all incoming BGP distributed subnets and export all subnets connected to the BGP on this VRF. So here is a router BGP configuration. The as usual, the router ID is defined for this particular router. I put 172.168.1.1 as a matter of best practice actually. I use this IP that is connected to the router end as a router ID. And then there is address family VPN v4 unicast is also enabled. This is required for IOS-XR, so we need to do this. And the rest of the configuration is VRF specific, so VRF, and then there is address family IPv4 unicast, and then the network on the left router is connected to 192.168.1.0. So this network is getting injected into the BGP configuration from this router perspective. The neighbor is 172.168.1.2, which is on the other router, and its ASN is 64997. The ASN of this router is 64999, by the way. And then there is an address family definition inside the neighbor as well. And then the route policy is added here in both in and out directions. In some advanced configurations, you can filter out only certain routes in and out. So in this particular example, I'm not doing any of that. I'm just letting everything go through in both directions. And this is it. So this is also duplicated on the other router actually. So now before we move on to the other router and then look at the same thing, let me run a few commands. Show IP route will show nothing because there is no BGP configuration or there is no routing at all on the global routing table, but there is routing table for the VRF. So 172.16.10 network is directly connected, as you can see, to the other router, and 192.168.10 is also directly connected to the other switch, the first switch on the left. And importantly, the other router injected 192.168.20 subnet to this router. So because of that, I should be able to ping the 192.168.20 endpoints, both the gateway and the PC, from the router on the VRF. So ping VRF, and then 192.168.2.1, and it is pinging fine, and then the endpoint, the PC as well. So now let's look at some other aspects, like show BGP will not show anything because we did not put anything in the global routing table in the BGP configuration. But if I do show BGP VRF, I should be able to see the BGP configuration. So there is a next hop 172.16.1.2 on the other router connecting 192.168.20 subnet. If I look at the same thing on the other router, I should see the 10 connector remotely through 172.16.1.1 and so on. So now let us go and take a look at the other router. We should see something similar, just for the sake of completion. So we should see something similar here as well, but with a different subnet. Show runtime configuration, the same VRF configuration here, similar, and also the bundle ether, and it is set as the bundle ID on the physical gigabit Ethernet 0000, and there is a bundle ether sub interface, and it is under VRF, and it has its own IP address. This is the gateway for the 192.168.20 subnet, and encapsulation.onq is enabled as well. And finally, the route policy, the same policy is applied here as well, and the BGP configuration is very identical but with different IPs. And from here I should be able to run this show IP route. Nothing should be on it. Show IP route VRF, and you can see the 1.0 192.168.1.0 got injected by the other router into this second router. And similarly, show BGP should not show anything, and then show BGP VRF. It is showing the neighborhood properly. Now let me try to ping the 192.168.10 subnet endpoints from this router, the second router, using the VRF. 192.168.1.1, that is fine, and 1.2 is fine as well. So now final verification, I want to go back to the PC1 and PC2 and try to ping the other counterpart, 192.168.2.2, and it is fine. And let me go to the second PC. It should be able to ping the first one, the left side. Okay, for some reason it is timing out. Let's see. .1 is fine. 2.2 its own is fine. 1.1. Okay, it's working now. I think some network glitch. Okay, it's looking good now. Okay, so I hope you enjoyed this video in which I kind of, for the first time in my YouTube channel, you started using the IOS-XR and defined the BGP relationship between a couple of IOS-XR routers, which is a bit different from the IOS-XC that I'm used to actually on the ASR 1K. So maybe in near future I will produce a lot more videos on IOS-XR to take advantage of the features that are specific to it. And thanks so much for watching, and have a wonderful evening or wonderful day wherever you are, and bye for now.